Right, hello there, and welcome to booklet 5, our final paper 2 specific booklet. However, at the front of booklet 5, or week 5 as we started calling them, weeks have become booklets, you can see exactly what you need to know for booklet 5. So it's everything from booklet 1, the bold things being higher tier only, so the back end of the paper. Some changing of the subject of the formula from booklet 2, which could be in either paper. It could be that this isn't even a question, really. It could be that you have to change the subject of the formula in order to do things like, I don't know, it could be anything. It could be even linked to the area of a triangle in booklet 3, because you have to kind of find the angle instead of the area. Something you're working backwards. You're having to rearrange formula. So it might not be its own question, but it's worth revising just in case it is. Booklet 3, everything. Again, a lot of higher tier stuff in there, some indices, some rational and irrational numbers, the sine, cosine rule, area of a triangle, and the conditional probability stuff at the end. And then this booklet, and then separately, ladies and gentlemen, in booklet 6, algebraic fractions and circle theorems, which are listed on both. We will touch upon some easy algebraic fractions in this one, okay? But for some harder ones, you'll need to go to booklet 6 and have a look at those two things on top of all that. So a lot to revise for paper 2. However, we'll have a better idea of what will be in paper 2, I guess, once we've seen paper 1. Okay, so let's get into booklet 5, starting with nonlinear graphs. I want to do some notes on these. It might be a slightly longer talk, but here we go. Nonlinear graphs. Right, first of all, let's talk about linear graphs. Linear means straight line. Linear graphs are y equals mx. This pen is just getting worse. I've made 3 booklets today, and every booklet is getting worse. Just go with it. I'll keep writing and just listening to what I say, okay? Where m is the gradient, and we need to know this actually for paper 1, not paper 2. It's in a different booklet to this. And c is the y-intercept. Okay. If the gradient is positive, the line is going up. If the number before x, the gradient, is negative, the line is going down. And the y-intercept is where it cuts the y-axis. Actually, where it cuts the x-axis, which is down here, completely irrelevant to a line, okay? That's all we need to say about those. Another type of graph, which is a non-linear one, looks something like this. Never touches those lines, just looks like it. This is called a reciprocal. And it will be something like y equals 1 over x, or 2 over x, or 3 over x, etc., etc. And that's what they look like. Just need to know that, nothing else to say on that one. Quadratic graphs, oh dear me. Quadratic graphs are y equals something x squared, right? Now, that might be it. That makes it a quadratic graph, just having the x squared there. Now, if a is positive, then it is U-shaped. If a is negative, then it is N-shaped, or an upside down U. Now, there may or may not be an amount of x's like we would see in a quadratic equation, and there may or may not be a number at the end. These do not change the shape of the graph. It's just that x squared that tell me what the graph looks like. However, like in a straight line graph, the loose number at the end is the y-intercept, not x, y, where it cuts the y-axis. Okay, so it could do this, or it could be upside down. Each having different y-axes here, okay? And the final type of graph I want you to be aware of is a cubic graph, which bends like a quadratic, but then bends again. All it needs to have to be a cubic is an amount, this time, not of squared number of x squareds, but an amount of x cubed. Now, there may or may not be some x squareds. There may or may not be some x's. Doesn't change anything. However, there is likely to be, like the other ones, a loose number on the end, and again, that loose number is the y inter, and I should say intercept if I can get this to write properly. Okay, right. The only thing I'd say here is, if it is positive, the a, the number before the x cubed, it will start by coming up, down, up. If it is negative, it will be down, up, down. Okay? Right. Pause if you want. Tell me what these are, whether they're linear, quadratic, cubic, or reciprocal. I'm just going to write the first letter. So what we've got, reciprocal, quadratic, but it's going to be one with a negative because it's upside down, but it doesn't matter. Don't have to do that here. Linear, but a negative gradient. Linear, but with a positive gradient. Cubic, because it bends twice. And quadratic, but with a positive x squared term, because it's U-shaped, not N-shaped. Here. The first one is linear. It's got a positive gradient and a negative y-intercept. So it's D. The next one is reciprocal. It's something over x, which is E. The next one is a cubic. Okay, with a positive, so it's coming up, down, up. That one is, okay. So where does that happen? There, C. Okay, the down isn't pronounced, but it's still curving one way and then curving the other way, even though it doesn't sort of reverse direction. Cubic just means bends twice. Bends one way, bends back the other way. Okay, it's cubic. The next one is quadratic. This shape, because it's positive, but cutting at -6, so it could be A. So that would be -6 there. And then the last one is linear with a negative gradient because it's -x and a positive y-intercept, which could be this one here, just B. True or false? Well, what do we know about these? The negative there means it should be coming down and down, okay? It also should cut through at a negative. The y-intercept should be negative, which it is. So potentially this is true. Here, it should be this shape, right? Actually, that doesn't change anything, all right? But there's no loose number without an x. Therefore, it should cut through 0. Almost think of it as +0. It needs to cut through 0, but it doesn't. It should have a loose number because you've got a y-intercept up there. It should have a positive. So this cannot be this for that reason. This is dodgy, right? Because we need to show an idea of what a negative indice means. A negative indice means 1 over. So that is the same as that, which is a reciprocal, which is exactly what that is. And here, I'm looking for that shape again, which I've got, okay? But I'm looking for it to cut at +4. Well, +4 would be up here somewhere. This isn't. This is cutting at 0. So actually, this must be false. This, I'm looking for a cubic with a positive y-intercept. Straight away I get it. This is a quadratic, this is a linear, this is a reciprocal, and this is a quadratic again, so they can't be that, okay? On to these. Now, slightly different thing. If the quadratic, okay, has been factorized for you, right? If the quadratic, like this one here, has been factorized for you, then your solutions to the factorized brackets are where they cut the x axis. Now this is a far more difficult version of this question. So if we look here, for example, okay, what we've got here, start with the easiest one. If I solve this, x minus 1 equals 0, so x equals +1, and here, 2x minus 3 equals 0, so x would equal, take the -3 over as +3 and divide by the 2. If you can find those two answers over here, then we can connect them up. here, I would end up with plus 3 over 2. And then the plus 3 actually would go over to make minus 3 over 2. So they are the two answers I'm looking for, which are here. Here, I'd have the same bracket twice. So either 4x plus 9 equals 0, or 4x plus 9 equals 0. That's another way of writing that, isn't it? So my answers for x, both my answers, would be minus 9, the plus 9 going over to make minus, and then divided by 4, or minus 9 over 4. Okay, but they're both the same, aren't they? Okay, so it's not that, because they are two different answers. It's that, to show that there is only one solution. And then the dodgy looking one, right? You almost have to think of this as being, right, I don't know, you might have to make a note on this, as being a bracket with like that. That times that bracket equals 0. So either, in this case, 0 is an answer, because the opposite of plus 0 is minus 0. Well, okay, the answer is 0. The other answer here would be the plus 3 would become minus 3 over 2. So I'm looking here, 0 is included, but also minus 3 over 2, which actually is down there. And then now I'm going back a page. An alternative to writing solutions is to draw a graph, and these two values here are where those graphs cut the x-axis. So, right, so my answers to this would be plus 2 and minus 2, and for that reason, that's there. But they are the reverse, if you see what I mean. They're trying to trick you here to go, oh, minus 2 plus 2. I can see a minus 2 and I can see a plus 2. You're looking for the opposite of these things, though. So here, I'd be looking for plus 1 and minus 4. Here, I'd be looking for 0 and minus 4. Here, I'd be looking for plus 4 and another plus 4. So, yeah. Here, I'd be looking for minus 1 and plus 4. Here, I'd be looking for 0 and plus 4. Here, I'd be looking for minus 1, and this is weird, isn't it? Because, right, actually, if you think of it, I'd have to write this. 4 minus x equals 0. So minus x equals minus 4 if I took that plus 4 over, but that's not, I don't want minus x. So if I kind of look at the opposite of that, so the other answer I'm looking for is minus 1 and 4. Now, that is the same answers as these. And I'm going to mention those in a second. Here, I'd be looking for 1 and minus 4. And here, I'd be looking for minus 4 and minus 4. So, first of all, only one x, only cut there, minus 4. So that's that one. This one, I'm looking for minus 4 and 0, which I'm getting there. Okay? Here, I'm looking for minus 1 and 4 as my solutions, which I have here, but weirdly, I also had here. So now I need more evidence than this. So I'm now looking at the fact that it's upside down, so it needs to be a minus x squared. Which one of those will give me that shape? And if you think here, that times that gives you minus x, so actually, minus x squared, sorry, so that's that. Whereas the one up here, the x times x, would give you plus x squared, so I'd be looking for that to be that shape. That also will give you a plus x squared. That will give you a plus x squared. That would give you a plus x squared. That would give you a plus x squared. That would give you a plus x squared. In fact, this is the only one on there that if I times the x by the minus x, I get the upside down shape. And here's another one, minus x times x. That would be upside down. And that would be that way, depending on whether the x squared is positive or negative if when I expand with brackets. That's a very tough start, and we'll leave that there for a second. Okay, the next section, formation and simplification of expressions, I'm not going to talk about to save time in this video. Just different words in algebra, okay? Simplify, which is the first figure, means bring things together. Bring your k's together, bring your m's together. But where would I quite encourage you to be careful? The second one, if that term is negative, people often read that as 5f, and it's minus 5f that I'm then adding 3f to. So if you think of a number line, minus 5, add 3, well, we're still at minus 2, aren't we? So 9g take away 2g is 7g, minus 5f plus 3f is minus 2f. You try those. Some expanding double brackets, FOIL or smiley face. So 5x times 5x, 25x squared. Minus 2 times 5x minus 10x. 5x times minus 2, same thing, minus 10x. And then the minus 2 times the minus 2, minus times a minus, making that plus 4. And what I've done then is I've collected together the two lots of minus 10x to make minus 20x in my final answer. So I've expanded and I've simplified. Remember though, that is a different term to the x terms. The x's can be brought together, x squared terms, different thing altogether. So let's expand. Then a bit of simplify, a bit of expand. Factorize is the opposite, put things back into brackets. In these easy cases, in your basics, you're looking for the biggest number that can be taken out of both terms. Here is 7 to leave a plus 3. Again, another double brackets for you to check, have a go at. Confirm you get the same as me. FOIL or smiley face, whatever you prefer. Expand in single bracket. So just times in everything in the bracket by the one thing outside. Again, expand in single brackets. Fair bit of factorising here. Somewhere we're taking out the highest common factor as a number. Okay, so what's the biggest number that goes into 14 and 21? Somewhere we're taking out a letter. So here, because there's an F in both, I've taken the F out. If I take one F out of there and an F out of there, I'm left with F minus 1. Okay, some dodgy, like this was dodgy because I was looking for a number, but there's no number that goes into 7 and 11, so the only thing that can come out there is an A. And I thought this one down here was a bit nasty because you can take out a number and a letter. So 3 times what makes 12? 4. I've already taken an x out, so I've only got one x left in that term. Plus 3 times what makes 3? 1. Okay. I've already taken the x out, so what have I got left in that term? Y. Here, ladies and gents, boom, boom, and then boom, boom, boom. So times what's in the bracket by outside, and then simplify. So we've got 5x squared minus 2x. And the reason I'm doing this is because of this being minus 3, didn't like it. Okay, times all these things in this bracket by minus 3. So minus 3 times x squared. Minus 3 times minus 2x makes that one positive 6x. And minus 3 times 7 is minus 21. Start by collecting together my x squared terms. So I've only got 2 left once I take away 3. Then minus 2x plus 6x is plus 4x. And minus 21 on the end, expanded and simplified. So that's the basic algebra. We're on to solving equations. Okay, here, magic bridge stuff. Okay, and then the times 4 becomes divide by 4 to give you this. Here, expand the bracket first of all, get rid of brackets. Then take your number, your plus 15 over as minus 15 to make 5 and divide by 10. And I put in my calculator 5 over 10 to get 0.5. Same things here, okay? The opposite of dividing by 9 times by 9. Plenty for you to try. Now I said algebraic fractions were in booklet 6, which they are, okay, on the front page, but these are also algebraic fractions of a simple form, and this is the form where the bottom numbers have to be the same. So what I would do here is try and make them all 10 by doubling that one, times in that one by 5, and times in that one by 5. But what I do to the bottom, I do to the top. So I've times the bottom there by 2, so I times the top by 2. I've times the bottom there by 5, so I times the top by 5. I've times the bottom there by 5, so I times the top by 5. So everything in that bracket is doubled, plus, that's what we got in the middle, everything in the second bracket I've had to times by 5, so it's 20x plus 25. And also the 11 I've got to times by 5. And once I've done that, I can then get rid of the bottoms. Now a little bit of simplifying. 24x plus 19 by collecting my x's together and my number terms. Take the 19 away from 55, gives me 36. Okay, sorry, that should say 24x. So x equals 36 over 24. Now if this were non-calculator, I would leave it like that. But because I've got a calculator, and if I put that in my calculator, it comes out to be 1.5. Lots more for you to try, okay? Lots more. Another example there of making the bottom numbers the same, I've chosen to times that by 3, so times the top by 3, and that by 3, so times the top by 3. The middle one I've left alone, and I've solved. And the only other one to mention here then, I guess, guys, is this one, where you've got a minus 5, which can go over as plus 5. But you've got a 9y, which can go the other way and become minus 9y. So 13y take away 9y is 4y, and 27 plus 5 is 32, giving you y equals 8. Any other issues there, do let me know. Using the quadratic formula, ladies and gentlemen. So what we're looking for is the number before the squared term is a, in this case it's 1. The number before the middle term, in this case is plus 5, is b. And the loose number, the y-intercept, which we now know that is minus 7, but that's c. So a, b, and c. And we copy the formula from the front, and wherever we see a b or an a or a c, put the number in brackets. So even when it's b squared, b, put it in brackets, and then write squared. Okay? I tend to, and I'm going to do this here, I tend to work the bit inside the square root out first. So here, in brackets, 5 squared, minus 4, in brackets, 1, close brackets, open brackets, minus 7, close brackets, equals. So, x equals minus plus 5, alright, or just minus 5, plus or minus the square root of, and I've worked this out now to be 53, divided by 2 times 1, which is 2, and this is where I would split. And I would do one example where I add the square root of 53 and get an answer, and then the second answer where I take away and get an answer, giving me 2 answers. Now, the clues. The clues for what we're doing here, it might not say use the quadratic formula, but we're in paper 2. Yeah, we're in paper 2, we're in the calculator paper, and it's saying, here's a quadratic. Even if it doesn't say quadratic, you'll notice, oh, it looks like a quadratic. Give your answer to 2 decimal places. There's your clues. I can see a quadratic, and also it wants 2 decimal places. So in the next one, I can't see a quadratic at the moment, but I am seeing solve, and I am seeing this 2 decimal places thing, okay? So can I make this look like a quadratic? Well, yes, I can. The opposite of dividing by 5x minus 3 is to put that in brackets and take it up there and times by that. I can then expand that bracket, and then the only thing stopping it being a quadratic is a quadratic equals 0. Okay, right. I am going to do a little bit more work on this one, because once I've got it to look like a quadratic, a is 5, b is minus 3. Problems when b is negative. C is minus 7. Why? X equals minus b. Put that in your calculator, both minuses. Minus b, but b is negative. Plus or minus the square root of b squared. You're not going to get away with this in your calculator. Think to yourself, what has he missed out? What does he always do when he substitutes your numbers in? I'm talking about myself in the third person. In brackets. So your calculator knows it's that minus 3 I'm squaring, otherwise it'll get it wrong. Okay? Minus 4, A, C, divided by 2A. Take your time, don't make mistakes. But look, that is important, that B being negative, that we ensure that when we put this in the calculator, we do it the same. Now, you can work out the inside the square root bit, okay? Should be positive if you get it right. Not check what you're putting it in right. You may have missed putting things in brackets, etc. But should end up with 2 answers then. Okay? Good job, good job, good job. This one, nasty. On the left-hand side, I've expanded the double brackets to get this. On the right-hand side, I've expanded a single bracket to get this, but I've got this kind of loose plus 7 on the end as well. I end up with a quadratic equation on both sides, but I don't want that. We've always said for a quadratic I want equals 0. So all of these things need to go over there. Take the 2x squared away from the 9x squared. take 3x away from minus 6x. Take 7 away from plus 1. Then we've got A is 7, B is minus 9, and C is minus 6. And you can have a go at solving. I haven't even done any work on this one, guys, because I think this one's quite easy. Expand your double brackets, work them all out, and then remember we want equals 0, so that plus 7 also needs to come over once you've expanded the brackets as minus 7, and have a go at it. Right, one of these type of questions, I'll show you, okay? It's a shape, it's giving me a quadratic, but it's part B that says solve. Go to the next one, it's part B that says solve. I do not want this work here being done in part A. I want it being done where I'm asked to solve. Part A says show that, prove that. It's always a little bit less marks. 3 marks there, 3 marks there. Whereas the part B, oh, okay, in this case, 3 and 2. It's gone against what I've said, but okay. Let's do the show bit first. Here, to show this quadratic is true, we are talking about the area of a trapezium. So I have written down the formula, and I know that it equals 25. Okay? Because I'm told the area of this trapezium is 25. Now, instead of A, I've put in that top bracket. Instead of B, I've put in that bottom bracket. Don't like this because these brackets aren't being times, they're being added together. So it's the top add the bottom. So if I, for example, if I add the x's first of all, it's x plus x, which is 2x. And then if I add the numbers 1 plus 2 is plus 3. So that's the top at the bottom, but I know I need to half that and times it by the height, and that the answer is 25. Now you've done a fair amount of work, right? You basically, right, you could get away with now going, da-da, I'm finished, and then you could write that, and I think you'd probably get full marks. But just to show why that is that, look at what we do here. If I times that by that, I get 2x squared. If I times that by x, I get the plus 3x. What I'm not seeing is plus 25, or this 25 here, but what if I took that over, the opposite of plus 25 is minus 25. So why is it minus 50? It's to do with this half. If this side of the equals, we are dividing by 2. If I move that over there, it's times 2. So 25 times 2 is 50. And when I bring that over, I end up with this. I get it that that's tricky. However, it's so tricky, they don't expect you to get it, which is why they're saying, okay, in this part, solve it, do the hard bit, get the main marks. Even if you can't do this, don't worry about it. Write it off. Don't worry about the show bit. Do the solve bit. A is 2. B is plus 3. Nice, not negative, thank you. And C is minus 50. But read the question. Okay? I'm actually going to do this. I'm going to do x equals minus b plus or minus the square root of b squared. It's nicer when that's positive, right? Minus 4 times a times c. C invariably negative. Okay, invariably negative. So don't miss that. If you put c in as plus 50, it will say error. Yeah, and you know, oops, made a mistake. I put something in positive instead of negative. Divided by 2a. Now, ladies and gents, boring bit for you. Try these on your calculator. I'm not going to bother. I'm going to go straight to the answer here. So my first answer is, chat amongst yourselves, as they say. Must be fun for you, right? So my first answer, if I'm correct, sorry, to 1 decimal place, as it says there, is 4.3. And my second answer, where I'm now going to do exactly the same calculation but with negatives, I am with you, I haven't left, is, okay, and again, please forgive me do try these. I'm confident I'm right, but I am rushing. Okay, minus 5.8. Now, this brings me on to what normally is a part C, like it is in this question. Evaluate your answer. In this case, it is impossible to have two answers, right? The lengths are either that or that. Now, the lengths cannot be negative. So at this point, you would say, you would circle this and go, that is the one I'm using because that is negative. And if there was a part C, you'd say, I'm not using minus 5.8 because it's negative, I'm using this. But my question here says, what are the lengths of AB and what are the lengths of DC? Well, AB is x plus 1. So 4.3, which is what I'm using as my answer, plus 1. That's the length of AB. And the other one is x plus 2, which is 4.3 plus 2, which is 6.3. So I'm using that. So don't miss that. I read what the question actually wants. Now, normally that's a different part, like here. Okay, evaluate the length of AC, justify the decision. So you'll go, well, here's what AC is, and my decision was I used my positive answer here. And even though I got a negative answer, I didn't use it. And that's the justification you put there. This one, though, the show bit was nasty, right? Because it talked about the area of a triangle. Now, the area of a triangle, I put, is it base times height divided by 2? Clearly not, because it's not a right angle triangle. Or is it the half AB sine C, which relies on the triplet? It is, isn't it? Yikes. Oh, dear me. So, I've written half AB sine C equals 6. I've put in that instead of A, that instead of B, and that instead of C, and it's there. Now, if you expand the double brackets, ignore the half. Well, first of all, the half, right? Take that over. Times that by 2. Right? And that's that gone. If we expand the double brackets, we're going to get 2x squared. We're going to get minus 2x and plus 3x. Nice. So that's that. But I'm also going to get minus 1 times 3, so minus 3, right? But what I haven't written is sine 30, right? If you put into your calculator sine 30, it's a half. That is a half. So again, ladies and gentlemen, if I took that up there, if that's a half, the opposite of half, which is divided by 2, is to times by 2 again. So that equals 24. And again, I know this is just not neat at all, but hopefully it makes sense to you. If I brought the 24 over there to be minus 24 and took it away from that, then I get this bit. So I have shown this. But again, I don't really care about the show part of a question like this. I care about the solve. I care about the algebraic method, which gives you the answer to 2 decimal places. I care about using the quadratic formula. Okay? Perimeter and area of shapes. Right. A triangle, base times height divided by 2. Don't need that. A trapezium, don't need to learn this. Actually given in the front of your book. The top plus the bottom, half it times the height. So I've written that. Times that. Here, the square, well, if the length of the square is 6.4, and we know it's a square because it says, then the width is also 6.4. So that's 6.4 squared. That's the area of that. The triangle, well, the base is 6.4, but what is the height? Well, if the total height of this shape is 10.7, but this bit of it is 6.4, what I've done is 10.7 take away 6.4 to give me 4.3. So the triangle bit is base times height divided by 2. And I'm going to add on to that the area of the square, which is 6.4 times 6.4. So you've got the area of the triangle plus the area of the square. Work it out. Again, I'm just trying to look, in this question, you'll be assessed for the oral, it's OCW, right? So bullet points. It tells you the area of the rectangle is 45. So therefore, 9 times the height here, or what we call the width, is 45. Therefore, the width is 5 centimeters. I'm putting in my units. I've bullet pointed what I'm doing. My next bullet point is working out the base of this triangle. It's like it's upside down. This is the base and this is the height. Yeah. The base of the triangle is 15 take away 9, which is 6. Therefore, the area of the triangle, which is what I need, is base 6 times height 5. So just work this out to be 5. Just work this out to be 6. Divided by 2. And units all the way through. 1 mark for bullet pointing what I'm doing. 1 mark for getting my units correct. If it's area, centimeters squared. If it's a length, centimeters, etc. Okay? I think you can do this, guys. That one. Have a look at it. And that one I'm going to back you. Okay? It's another one. Look, we've given the area of the rectangle. We're missing that. If it's OCW, right, the area of the rectangle equals 7 times x, or length, or whatever you want to call it, which equals 91. Therefore, x equals blah, blah, blah. Okay, 13 or whatever it is. Once I know that's 13, the area of my trapezium equals half a plus b times h, which is blah, blah, blah. Work it out. Bullet point, units, just get the full marks for me, yeah? And the same there, a rectangle with a trapezium. Right, we know that's 7. What else? Oh, the perimeter of the rectangle is 24. 9. Okay, a bit nasty, yeah? Okay, so if I was OCW in this, I would say the perimeter of the rectangle is 24. But if I take away 7, the bottom and the top, I'm down to 10. Therefore, the width is 10 divided by 2. So they must be 5 and 5. And again, I drop marks because I've forgotten to write the units, and this is OCW. Right? But if that's 5 centimeters, then that must be 4 centimeters because they add up to 9. And I now have enough information to work out the area of the trapezium. I've got the top, I've got the bottom, I've got the height. Okay, bit of a look at circles, I guess, just in case. We've done trapeziums, triangles, etc. We might as well. Here, it's a square. If that's 4.2, then that's 4.2, right? Therefore, the length of the square is 8.4. So the area of the square is 8.4 times 8.4. The area of the circle is pi times the radius squared, which is that. So the shaded area is the square take away half of the circle's area, which has been chopped out. So I've put the square take away the semicircle. So there's the area of the square, and the area of the circle, which is here, I've divided by 2 because I only want half of it being chopped out of the square on my final answer. Have a little look at what I've done there, guys. And this, it wants the circumference of the circle, so it's pi times the diameter, and we worked out that the diameter is 20. Okay, the next section, surface area, area cross sections, volume, and density, mass, volume, follows on nicely from the basic area and perimeter questions that we've just done. Okay, rather than me jump straight into the questions that you can see there, I've put this little snippet from the formula sheet because we're going to be using all of these. Okay, so just so you're aware that they're there. Okay, what we've got is the area of a trapezium, which we've already used a lot of, but it is there. The volume of a prism. What a prism is a 3D shape, which is the same all the way through. Now, it depends what the cross-section is. I much prefer the word depth to length, but hey-ho. So what I've done up here really badly is said, well, if the cross-section is a circle, if the shape is a cylinder, then the area is pi r squared times the depth. If it's a rectangle, it's length times width times the depth. And if it's a triangular prism, it's base times height divided by 2 times the depth. And my answer to a volume is likely to be in centimetre cubed or metre cubed or whatever, okay? Surface area is a different thing. Surface area is the combined areas, so add up areas, okay? And what I'm going to put the term is of faces you see. So if two shapes are stuck together, you wouldn't see the faces that are in between the two shapes. So it's any face you can see. It could be a circle, a rectangle, a trapezium, whatever faces you can see. We're going to work out their areas individually and add them up. But we need to show an awareness of what those faces look like, okay? Now, The two higher tier ones are spheres and cones, and I don't like the cone one. Listen very carefully. Something right that I mentioned in class, but not right. This should read 1/3 times the area of the base times the height. Now it just so happens in a cone that the base is pi r squared. However, it's worth noting that if this was something like a pyramid, then the base, okay, is a square. So it would be 1/3 times the square, or whatever you want to, times the height. So it literally, if it's a cone or a pyramid, it depends what the base is as to what goes in there. Be aware of it, okay? Also, the other thing that I'm going to pick up on here is in terms of the surface area, okay, for the sphere, it's given, and for the volume of the sphere is given there. Both rely on knowing the radius. Here, for the volume of the cone, I'm interested in R and H, which is the straight height. For the curved surface area of the cone, so not including the bottom circle, just the curved area, then to work out the curved area, you'd need pi times the radius and times L, which is the slanted height, as opposed to the straight height. Other things I just want to mention here, okay, are conversion of units. Make sure that all your units are the same on the shape. They're all centimetres or all metres or whatever you want to know. And a couple of conversions for you at the end. If it asks you to convert your centimetres cubed answer into litres, okay, 1 centimetre cubed is a milliliter. So that is dividing by 1,000, right? However, if it asks you to convert your answer from centimetres cubed, for example, into metres cubed, that's tricky. Because whereas 1 metre is 100 centimetres, 1 metre squared is 100 times 100, which is 10,000 centimetres squared. And 1 metre cubed is 100 times 100 times 100, which is 1 million. And I'm going to mess this right there. Centimetres cubed. So if you wanted to change centimetres cubed to metres cubed, you're not dividing by 100, you're actually dividing by 1,000,000. Okay, so be careful, it could ask for either of those conversions. Just write them down, be aware of them, and we'll have a look at them as we go through. The other thing, it could tag a volume question into a DMV question, right? Written in that order: density, mass, volume. So be aware if we've worked out a volume, it might say, right, Poppy, now we've got the density, or now we've got the mass, or something like it. Let's jump in. Okay, starting with a cylinder, calculate the volume. Okay, the volume is the area of the cross section times the depth. So in this case, the cross section is a circle, so it's pi r squared times the depth. You can work it out, and the answer is in centimetres cubed because it's a volume. What is the greatest number of litres that the cylinder can hold? So we need a conversion into litres. Well, let me actually work this out for you. The answer was 6,280, if you put that in your calculator. If you divide that by 1,000, which takes it into litres, it's 6.28 litres. So the biggest amount of whole number of litres that it can hold is 6 litres. Part A, I know people are missing the questions which I've written on the side here. The two cuboids shown below have equal volumes. So this one is 6 times 2 times 3. Please, I don't do things with OCW. You need a bullet point. The volume of cuboid A is, right? And your answer would be 36. And again, give your unit centimetres cubed. You get that wrong, you drop a mark, right? The volume of cuboid B is 2 times 2 times H. But we know that we want the answer 36. Therefore, H equals 9 centimetres. Okay. I will do this because lots of people get it wrong, okay? The surface area, okay. On cuboid A, the front is 6 times 3. The back is also 6 times 3, so there are two 6x3s. The top is not 6x3. The top is 6x2, and the bottom is the same, so there are two of those. The side is 2x3, and the other side is the same, so there are two of those. Add those all up, get your surface area of cuboid A. Whereas on cuboid B, that is 2 times 9, the side is 2 times 9, the back is 2 times 9, and the other side is, so actually there are 4 of those, and then the top and the bottom are both 2x2s, so slightly different look to that one. And he says, write that as a fraction of that one, so whatever that one is, put it on the top, and whatever that one is, put it on the bottom, and unless it asks you to simplify, you don't need to. Calculate the area of triangle ABC, first of all. Let's break this up for us. So base times height divided by 2, but I don't know the base. But I do know the big side. So we're going to need Pythagoras to work out the base. So do that for me, okay? So square, square, subtract, square root, because we're trying to find a smaller side, okay? Square the 35, square the 21, find that. Work out the area of the triangle. Next. Calculate the volume of the prism. Well, all that is the area of the triangle that we've just worked out times the depth. But I've got another issue here. Look at your units. Centimetre, centimetre, oh, it's meters. Just a spot. Fab. So times your answer by 200. Your answer now will be in centimetres cubed, whereas this would be in centimetres squared. Okay. And the density is 1.6. So we're talking about density here. The density, and I like to write it on, is 1.6. The volume I know because I've just worked it out. And he wants the mass. Okay, well, I've got to do 1.6 times the volume. However, my density is in grams per centimetre cubed. So when I times it, the answer I'll be get is in grams when I do my answer there times 1.6. I need to divide that by 1,000 into kilograms. The surface area, here we're given the answer and we're going to find x. So basically, the front would be, if you could draw it, but the front would be 7 times x. The back would be 7 times x. The top would be 5 times x. The bottom would be 5 times x. Whereas the sides would be 5 times 7. And the other side would be 5 times 7. And the combined surface area is 142. Okay, collect everything together. And you go ahead and solve that to find x. Again, volume of the, I'm not even looking at the question here, I'm guessing, right? The volume of the cuboid would be 20 times 15 times 10. The volume of the cylinder would be pi times the radius squared times 10. So you've got the difference between length times width and pi r squared, but both depth, the depth of both shape is 10, if that makes sense, okay? So assuming that that hole has been cut out, I'll be taking that volume away from that volume, and my answer will be in centimetres cubed. And then I'm given the density again, so the mass is the volume from part A times the density, because of D. I should have written those the other way around, shouldn't I? D times V, same thing, okay? And again, though, your answer will be in grams, because of the units there, but it wants it in kilograms. So you need to divide by 1,000 and to the nearest kilogram. Now, the next question is only about density, nothing to work out. So what we've got here is two skateboards, Finbar and Sabs, okay? Area, another word for thickness, depth. Times those together, I get the volume of that one. Times those together, I get the volume of Sab's skateboard. I'm then told what they're made of, fiberglass. Fiberglass has a density of 2.6. Maple wood has a density of 0.7. So I will now know the volume and the density and I can use that to work out the mass, again, by doing density times volume. I can work out the mass of a Finbar skateboard, I can work out the mass of Saab skateboard, and I can work out how much heavier Finbar's is than Saab skateboard by taking them away. Okay. A cone is joined to a cylinder, okay, and I want the surface area of the composite solid, so the full thing, right. Here, notice that circle is not part of the surface area because it cannot be seen. I can see it on the picture, but if I stuck a cone on top, so all I want is the curve of the cone, which is equal to, if I scroll back up, the curve of the cone is pi RL, where L is the slant. Let's do that. I want the bottom, which is down here, which I would be able to see, the underneath, which is a circle, so it would be pi r squared. And I want the curve, and this is the hard bit, I guess, of the cylinder, and this is our first attempt at this, okay? The curve of a cylinder actually is a rectangle where, okay, it might be better actually, we will come back to that, we'll put some numbers on, right? The cone has a base radius of 11, that's nice, okay. It has a slant height of 13, that helps as well, the slant height, which is the one I want, which is L, okay. The cylinder has the same radius, 11, and has a height of 17, okay. So for my curve of my cone, it's pi times the radius times the slant height, you can work that out. For the bottom, it's pi times the radius squared. And for the curve of the cylinder, okay, it's length times width, because it's a rectangle curved up, where the width is 17, and the length is equal to that which is the diameter of the circle. So the length of the rectangle is pi times the diameter of the circle, which is double the radius, which is 22. So my curve would be pi times 22, which is the length of the rectangle, times the width of the rectangle, and I'd work that out there. I then have my three important surfaces, the curve of my cone, the bottom, and the curve of the cylinder, and I can add them all up to get the total surface area. We said here, for a cone or a cylinder, the volume is a third times the area of the base times the height, okay? And literally, we're told the area of the base and we're told the height. It's going to be a massive answer, right? The answer is going to be in centimetres cubed, but what does it want me to do? Change to meters cubed, the awkward one, because it's not divide by 100. Think back, what did I say? It's divide by 100 times 100 times 100. So it's actually to divide your answer by 1 million, okay, to get it into meters cubed. So that's dodgy, right? Reading involves just reading. What does it want my answer in? What have I actually worked it out in, etc. Half of a sphere. Calculate the surface area. So what I want here is the surface area of a sphere. I'm literally doing all these questions, aren't I? Which is 4 pi, see here? Okay, 4 pi r squared. 4 pi r squared, 4 pi r squared, 4 pi r squared. I'm just trying to remember it myself because it's talking about surface area. So it's 4 pi r squared. However, that would be if it were a full sphere. I'll need to divide that by 2 because it's only half a sphere. That would give me the surface area, or the area of the curvy bit, the ball bit of it, the sphere bit of it. But actually, because I've chopped it in half, I've actually got a surface here as well, which is a circle. So I'll need to add on to that the area of that circle, which is pi times. So all I'm going to do is put 29 into there and work that out. And the answer would be in centimetres cubed. No, it wouldn't. It's surface area. It'd be centimetres squared. Same thing here, guys. okay? If I want the surface area, I want the curve. All right, so this is what the one we just did a couple there. I want the curve. That's the awkward bit because that actually is a rectangle, and I want the circle underneath, and I don't actually care about that bit because that's hidden. And I'm going to leave that one as well. Okay, and to end this, and I'll do a bit more of these in class then, okay? We won't have time to do lots here. The length of an arc is pi times the diameter times the fraction of the circle that you've got. The area of the sector is pi times the radius squared times the fraction of the circle. So basically, the fraction of the circumference and the fraction of the area. But also, they might tag into this question, because it's a massive higher tier question. They might tag in the area of a triangle with the higher tier version of it, half AB sine C. So what I've done a basic one here for you, okay? The perimeter of the sector is 7 plus another 7 down here, plus whatever this arc length is. And to work out the arc length, I've done pi times the diameter, which is double 7, which is 14, times the fraction I want, which is 42 out of 360. The answer to that was 5.1, which is this bit, 5.1. But the full perimeter then, I'd have to add on both 7s to get the full perimeter. The area of the sector is pi r squared, pi times 7 squared, times the fraction I want, which is 42 over 360, and I get 17.95, and I've chosen to give that to 2 decimal places instead of 1, but I've actually said here what I've rounded to, which is always a nice thing to do. Here. Bit of a weird one. It tells me the area, yikes, and it tells me the radius, and what it asks me for is what the angle is. So I've written out, I don't know why I've written half, that's so weird. That should be pi, okay, times the radius squared times the angle, but I don't know that, over 360, but I do know the answer. So pi times 100 and it doesn't matter what order I do this. The opposite of dividing by 360 is to times by 360, and the opposite of timesing by 314 is to divide by 314. So theta equals, I'll actually do this one, 65 times 360 divided by 314, which is 74.5 degrees to 1 decimal place. Hence, calculate the length of the arc. Well, now that the length of the arc is pi times the diameter times the angle over 360, but we know both those things, okay? We know that the diameter is not 10, it's double 10, which is 20, and we know that the angle there, well, we just worked it out to be 74.5, and you can work that out. Okay, the length of the arc again, here's your angle, and your diameter is 6.2. Use that, do that with me. And I think there's a few more tricky ones, isn't there? Let's just do this one. This is nasty, okay, because it tells you, what does it tell you? It tells you the area of the triangle, right? I'm going to do that in class, so I'm not going to do that here. Also, I'm going to let you have a look at the top, and I'm just going to end this by this one here, okay? Which tells me, well, first of all, there's 2 area things going to happen here, isn't there? The area of the sector is pi times the radius squared times the angle over 360. The area of the triangle, which is the whole thing including the sector, is half A B sine C. Okay, what do I know? Right, CEA, which is this one, is 34. Mark it around lush. ACE, which is the full angle here, is 100. Now, before I even go on, I can work that one out. So I've got 2 angles here, 134 from 180. Right, write the workings out, don't just assume it's 46. That helps. Right. I'm also told that C to E, which is this one, is 12. Oh, I've just noticed they actually told me that. There was no need to tell me that. It's just giving me, at least make me work that one out. Okay, it's 12. Okay. In order to work out the area of the sector, this bit, I am going to need to know that. The radius of the circle. I know the angle, I don't know the radius. Okay. In order to work out the area of the triangle, I'm going to need a triplet, side angle side. All right. Well, if I know this, I will have side, this angle, and this side. So I can work out the area of the triangle also. But both these depend on knowing x. Okay. How can I work out x? Right. It's at the end of paper 2. It's got to be. It's not a right angle triangle. So it's not like a SOHCAHTOA or a Pythag or anything like that. It can't be. But what I've got a complete pair and an incomplete pair. I'm going for it. I'm doing the 8 marks. Okay, it's going to be a mess, but I'm doing it. So to get x over sine 34 equals 12, this side here, over its opposite pair, sine 46. Should really put those in brackets. Again, guys, the opposite of dividing by this is the times by it. Up there. So x equals 12 divided by sine 46, close brackets, times sine 34. Nope, can't do that. Need to get the answer to that first. Then press times sine 34 is 9.3 to 1 decimal place. So the sector is pi times the radius, which I've just worked out, squared, times the fraction, which is 46 out of 360, if you imagine that circle continuing all the way around, okay, which equals, talk amongst yourselves again, times 46 over 360, which is 34.7 to 1 decimal place, centimetres squared, whereas the triangle is half A, which I'll take to be the 9.3, yeah, B, which I'll take to be the 12, sine big C, which is the enclosed angle, which in this case is 100. Again, I've started, so I'll finish. 1 over 2, that's a half, times 9.3 in brackets, then in the next set of brackets, 12, and then sine, and in the final bracket, 100, close brackets, equals 54, effectively 54.95, but if I round that to 1 decimal place, it actually just becomes 55. So the shaded part is the triangle, take away the sector, which is 55, take away 34.7, which is 20.3. Okay, okay. Here, ladies and gentlemen, it tells you that AD is 3. Okay. It tells you the angle as well, which is very nice. It tells you that that's 38 degrees here. So you can work out the area of the triangle because you've got the triplet. You can also work out the area of the sector, which is the whole thing, because you've got the angle and you've got the radius of 7, and then just literally take the triangle. Whereas here, it was taking the sector away from the triangle. Here, it's cutting the triangle out of the sector. So sector minus triangle. Okay? And then the last bit here, calculate the perimeter of the shaded region. Easy enough, right? Tells you that the radius is 7.3. But because we're talking about, we need the arc length, not the sector area. So it's pi times the diameter times the angle. And the diameter is double the radius, so I'm going to be using 14.6 there. That gives you the length of this. You will then need to add on that 7.3 there, and add on that 7.3 there to get the total perimeter of that. We finished. Hurrah! All the very, very, very best. That's it. All videos done, all uploaded, good to go. And see you next after half term.